Hello everyone. We're going to today talk about the angles in polygons. And so first we're going to do a little exploration to kind of figure out what is happening in these polygons, okay? So what I'm going to do is we're going to go through and we're going to record certain information about these different polygons. So we'll start with a four-sided figure, which is a quadrilateral. So we have four sides, and then we're going to draw a line through the diagonal. And when we do that, we're going to look, okay, how many triangles do we have when we drew that line? Well, we have 1, 2. So there are 2 triangles. And then when it says total degree measure, what we're going to look at is if we have, so this triangle right here, its 3 angles are going to equal 180. And then our second triangle, its 3 angles also measure 180. And so if I look at that, I can notice that that is, if I add those 2 together, the 4 angles of my quadrilateral. So I know that the angle of these 2 triangles, the angles of the 2 triangles all together is going to be 2 times 180, which is going to be 360. And that is the total degree measure of the angles of my entire quadrilateral because they all add together. Okay, let's look at my next shape. So next is a pentagon that will have 5, and we can go through and we can just label all of these really quick. Okay, so next I have a pentagon, and I'm going to do the same thing. I'm going to draw some triangles. So there's one right there, and then I'll draw another line there. And so now I have 1, 2, oh my, make that back into the pen. 1, 2, I have 3 triangles. So that means my angle measure, if I add up the angles, oh my goodness, of my triangles, so all of them will equal 180. And once again, if I take all of my triangle angle measures, I notice that I get all of the angles in my pentagon. So now I have 3 times 180, and that's going to give me 540. Okay. Work on my next one. Let's see, I'll draw one there, draw one there, and one there. Okay, so I have 1, 2, did it again, 2, 3, 4 triangles. Hopefully you're noticing a pattern. Okay, and so all of those angles together will give me the total angle measure of my hexagon. So that's going to be 720. Keep going. Ooh, that was terrible. That's kind of a curve, but we're going to pretend it's a straight line. My straight lines are getting iffy. Okay, 1, 2, 3, 4, 5 triangles. So the total angle measure is 5 times 180, which is 900. And then for my octagon, these ones are harder to draw. I've got, hopefully you can see the pattern. So even without counting, we know this is going to be 6. 6. Because each of these numbers is subtracting 2. So the number of triangles is 2 less than the number of sides in the polygon. And if I add the angles of the triangles together, I know that that gives me the total angle measure of, let's see, that's 1080 of the polygon. So the number of triangles is 2 less than the number of sides, and the angle measures of all the triangles put together give us the angle measures, the interior angle measures of the polygons. Okay, so hopefully we noticed that pattern. So if I had, say, that's not going to work. I should have done this earlier. That's not gonna work. So let's say I have something that is going to have, I'll go over here. Let's say I have a 12gon. The number of triangles would be 10. And so I would find the interior angle measures by doing 10 times 180. Give me 1800. If I had a 23gon, I know that there would be 21 triangles based on my pattern. So to find the angle measure of my 23gon, I would do 21 times 180. And that is whatever that is. Okay? So this is where this comes from. So this is, if we go to our next page, called the Polygon Angle Sum Theorem. And I know this says and every year I say I'm going to change this, and every year I do not. So that's just where we are. Okay, this is the Polygon Angle Sum Theorem. That might sound familiar because we've talked about the Triangle Angle Sum Theorem. And the Triangle Angle Sum Theorem tells us that the measures of a triangle, the measures of the angles of a triangle equal 180 degrees. So the Polygon Angle Sum Theorem says the following. For any n-gon, so remember n is just the number of sides, so any polygon with n sides, the sum of the measures of the interior angles is, and let's think about what we figured out previously. So back here, we knew that for whatever our number of sides is, that's n, we subtracted 2 to find the number of triangles. So we know we had n minus 2, so that was the number of triangles. And then we took the number of triangles, and what did we do? We multiplied by 180. Okay, so we're going to take our number of triangles, which is the number of sides, minus 2, and we're going to multiply by 180. And so this formula right here tells us what the sum of the interior angles for any polygon is. Okay? So there is a corollary that goes with that. So that's kind of a mini theorem that drops out of our main theorem. And so that says for any regular, and remember regular means that all of the sides are congruent and all of the angles are congruent. Okay, so for any regular n-gon, the measure of 1 interior angle is, and let's think about this. So let's say that I had a regular pentagon, okay? So we found out over here that pentagons, let's see, here's my pentagon. Pentagons, their interior angle adds to 540. So if I have a pentagon, let's say it's 540 and it's regular. So regular means all of the angles are congruent. If I wanted to find 1, the measure of 1, how would I do that? Well, if the angles add to 540 and all the angles are the same, I'm going to just divide by the number of angles, right? 540, all of them together, divided by 5 gives you the measure for 1. All right, so that means that we're going to take our formula over here. So n minus 2 times 180, and we're going to divide by the number of angles that we have, which is the same as the number of sides, which is n. Okay, so these are our two big formulas that we need to know. So this gives us, our first one gives us the measure of all of the angles, and our second gives us the measure of one angle if we have a regular polygon. Okay, now we have one more. It's called the exterior angle sum theorem. And the exterior angle sum theorem is way more simpler. That's not how you said it, is way simpler, or way more simple. So the exterior angle sum theorem says the sum of the measures of the exterior angles of any polygon is, ready for this, 360. It's just 360. There's no fancy formula for any polygon you could possibly come up with. If you add all of the exterior angles together, it's going to give you 360 degrees. And let's talk about why that is, okay? So first, let's talk about what an exterior angle is. So a common misconception is that an exterior angle is this right here, and that's not correct. That is not what an exterior angle is. An exterior angle is an angle formed if we take a side and we extend it outward. This angle right here is our exterior angle. Okay, so we could do that for all of our angles. There's 3. Let's see, we'll extend this one. There's 4. And this one right here is 5. Okay, so if I add all 5 of those together, plus measure of angle 4, plus measure of angle 5. So I'm sorry, did I say all 4 of those? All 5 of those together, we are going to get 360. And it would be the same if it was a quadrilateral. It would be the same if it was an octagon or a 23gon. And the reason being, think about what happens as we add more sides. As we add, and it stays, especially if it stays regular. If we add more sides, this angle is going to get bigger. And as this angle gets bigger, what's going to happen to this angle? Well, this angle is going to get smaller. And they're going to get smaller proportionally so that their sum is always going to stay 360 degrees. Okay, so let's find that measure of 1. Let's say we want to find the measure of angle 2. Let's say this is a regular pentagon. So to find that, we'd say the measure of angle 2 is going to be 360. All of these are congruent because this is regular. So just 360 divided by 5, which is 72 degrees. That's also the measure of 1, 2, 3, 4, and 5. That's the measure of all 5 of them. Okay, let's talk about also using this same pentagon. Let's find the sum of the interior angles, just so we can practice. So the sum of the interior angles, so we do n minus 2. Let's go back up. So that's our number 1. So it's n minus 2. N is 5. So the number of sides minus 2 times 180. So that will be 3 times 180, which will give us 540 degrees. Okay? Now, what if we wanted to find the measure of one angle? Well, in that case, we would take the measure of all of them, which is 540, and divide it by the number of angles, which is 5. And once again, remember, this is assuming this is a regular polygon, which I'm telling you it is. We can even mark it. Okay? Which is going to give us 108 degrees. Okay? Let's look at our last page with an example. These are both the same example, so we're just going to do the top one because it's identical. Okay, so this says find the measure of angle y. So what we have to do to start is we need to figure out what the sum of all of the angles are together. Okay, so let's count. We have 1, 2, 3, 4, 5. Okay, so this is a pentagon. Okay, so the sum of all of the angles is going to be, we just did this, but we'll do it again. 5, that's the number of sides or the number of the angles, it'll be the same, minus 2 times 180. And as we figured out previously, that's 540. And so now we want to figure out what y is, what the measure of angle y is. And we know all the rest of them, which is helpful because this is not a regular polygon. Since it is not regular, we cannot just divide by 5. That will not work because they're not all congruent. So what we're going to do is the same thing we did with when we were dealing with triangles earlier in the year. We're going to add all of them together and set them equal to our sum, which is 540. So we're going to have, let's see, if we start with A, we'll have 150 plus 120 plus O is a right angle, so I know that's 90, plus 110 plus whatever y is. That's our variable. Equals, and we know all of those together equal 540 because we figured that out up here. Okay, so now we'll do some math. We're going to get 470 plus y equals 540. And so then if I do my subtraction, I know that the measure of angle y is going to equal 70 degrees. Okay, so that is finding angles of polygons. So remember, our big concepts were right here, the measure of the sum of all of the angles. We have right here the measure of just one if it's regular, and then this was our third. and that was all of the exterior angles add to 360 degrees, no matter what type of polygon it is.